So here we shall explain some standard integral formulas using trigonometric substitution. So suppose we need to find the integral of tan x dx. So that will be, so here we can write tan x as sec x into tan x dx divided by sec x. So if we make the trigonometric substitution, if we make the substitution, that is, let sec x equals to t, then the differentiation of sec x means dt by dx, that will be equal to sec x tan x, means it will be d by dx of sec x, so that will be sec x into tan x. So now so this is dt by dx, so therefore we can say that dt equals to sec x into tan x dx. So therefore this sec x into tan x dx we can write it as dt. So this will be integral dt. So this is dt by t. So therefore the integral of dt by t, so that will be log mod t plus c. So therefore this t is sec x, so this will be log mod sec x plus c. Okay. Then the second is integral cot x dx. So that will be, so here cot x we can write it as cos x by sin x dx. So here also put if we put sin x equals to t, sorry, if we take sin x equals to t, then dt by dx, if we do, that will be d by dx of sin x, so that will be cos x. So therefore cos x dx can be written as dt. So here we have made this trigonometric substitution, means sin x we are taking it as t, then we get cos x dx as dt. So this will be also integral dt by t, so which can be written as log mod t plus c. So t is sin x, so the answer is log mod sin x plus c. And the third one, suppose we need to find the integral sec x dx. So this sec x, I can write it as sec x into sec x plus tan x dx divided by sec x plus tan x. So here also we can make the trigonometric substitution. So suppose if we put t equals to sec x plus tan x, then dt by dx, that will be equal to d by dx of sec x plus tan x. So then, so this will be d by dx of sec x is sec x plus sec x tan x plus d by dx of tan x is sec square x. So this can be written as sec x, I can take it as common, and this will be sec x plus tan x. So therefore, hence this sec x into sec x plus tan x into dx, that can be written as dt, if we take t as sec x plus tan x. So therefore, this is also integral dt by t. So this is log mod t plus c. So hence t is this. So we can write the answer as log mod sec x plus tan x plus c. Okay. Then the fourth one, if it is asked to find the integral of cosec x dx, so that will be equal to, here cosec x also we can write it as integral, this is cosec x into cosec x plus cot x divided by, this is cosec x plus cot x into dx. Okay. So now here also, if we make the substitution, if we take suppose cosec x plus cot x equals to t, then uh, so dt by dx if you do, then that will be d by dx of cosec x plus cot x. So therefore this will be equal to d by dx of cosec x. So that will be cosec x into cot x, then plus cot x. So d by dx of cot x is minus cosec square x. There is something wrong here. D by dx of cosec x is minus cosec x cot x. So here, if you take minus cosec x as common, then this will be cosec x plus cot x. Okay. So therefore, this cosec x, so dt by dx is this. So minus cosec x into cosec x plus cot x dx, that will be equal to dt. Or we can write cosec x into cosec x plus cot x into dx, that will be equal to minus dt. Okay. So this can be written as minus integral dt by t. So this will be minus log mod t plus c. Or this minus, I can take it as the exponent of t. So that will be log of 1 by mod t plus c. So this will be equal to log mod mod of 1 by cosec x plus cot x plus c. So now we also know that cosec square x minus cot square x, that is equal to 1. We know this. So therefore, this cosec x, so if we factorize this, this will be cosec x minus cot x into cosec x plus cot x, that is equal to 1. So cosec x minus cot x, I can write it as 1 by cosec x plus cot x. Hence, this can be written as log of mod of cosec x minus cot x plus c. So this is the value of the integral cosec x dx. Okay. Then the fifth one. Okay. So based on this, we can solve some examples. We can do one example, that is, so suppose if it is asked to integrate cot x into log sin x dx. Okay. So then, so here if we take log sin x, that is equals to t, then dt by dx, that will be equal to d by dx of log sin x. So here we have to apply the chain rule. So here we know that d by dy of log y, suppose if you do, that will be equal to 1 by y. So this will be equal to 1 by sin x into d by dx of sin x. So that is cos x. So this will be equal to cot x. So therefore, cot x dx, that can be written as dt. So this is integral t into dt. Since cot x dx, I can write it as dt. So this will be equal to t square by 2 plus c. So this will be 1 by 2 into t square. So this will be log of sin x whole square plus c. Okay. So this is the final answer for this. Then in the same way, uh, we can do one more question based on the trigonometric substitution. Suppose it is being asked to integrate uh, dx by cos square x into 1 minus tan x whole square. So this can be written as, so 1 by cos square x, that is sec square x. So I can write sec square x dx divided by, this is 1 minus tan x whole square. So now here we can also make the trigonometric substitution. That is, here let us take 1 minus tan x, that is equals to t, suppose. So then dt by dx, that will be equal to d by dx of 1 minus tan x. So that will be equal to minus sec square x. So hence sec square x dx, that can be written as minus dt. So this integral we can write it as integral minus dt by, this is t square. So this will be minus of, so it is, this integral is t power minus 2 plus 1 by minus 2 plus 1 plus c. So this will be minus 1, and this is also minus 1. So this will be plus 1. So this will be t power minus 1. So it is 1 by t plus c. So the answer, the required integral, the answer is 1 by 1 minus tan x plus c. So this is the answer. Okay, thank you.